Hey, welcome back. Let's take a look at light. Light has two different properties. One of them is a wave property, which we are very familiar with. And we know that because there is a giant spectrum here, we see, of waves. This is called the electromagnetic spectrum. Now, every wave known to man is here, as far as we know, and light occupies a very small sliver here. This is light that we can see with our own eyes. Inside that light is every color that we see, and you notice that there's wavelengths for all these colors. So every color that we see corresponds to an actual wavelength of light. Now, if you take a look at the spectrum, you also see up here on top frequency, and on the bottom you see wavelength. So we see that every wavelength has a frequency, and that can be seen by the equation C equals lambda V, where lambda here is the wavelength and V here is the frequency, and C is the speed of light, which never changes. So what is frequency and what is wavelength? Frequency is how often something occurs. So here is a wave, and here is a wave. This one has a higher frequency. You can see more often the wave occurs. Okay, whereas here the wave does not occur as often. Second, we have wave length, and that is measured from the apex to apex of the wave. That is wavelength. How far apart are the waves? And we can see here that this wave is closer together than that wave. And just from the picture, you can see that there is some kind of a correlation between frequency and wavelength just from the way that they're drawn. Okay, so light as a wave. See you next time. Bye-bye.